episode of the Envision podcast. So you're all welcome, water warriors. Welcome back to the Envision podcast. So here we're going to talk about the power of water and the science behind sustainability and innovation shaping our future. Right. So just to let you know, I'm your host Victoria Ihenetu, and today we'll be taking a deep insight beneath the surface. So literally we all know that yes, with water we see it literally in the surface, but we don't get to know what happens in the subsurface. So this time around we're going to talk about what happens beneath the surface, and quite literally our topic is we're talking about geotechnical frontiers. Yeah. So what comes to your mind when you hear about geotechnical frontiers, right? So when you talk about bringing geology and then you're bringing some technological aspect to it, right? So now geotechnical frontiers, building sustainable water system in a changing environment. In a changing environment, how do you build a long-lasting, sustainable water for the people in the community, for the people in the region, or for the people in the country? All right. So we'll be moving further. So now, can the way we build underground help us survive above ground? So it's a question. I'll call it a question. A question whereby you need to ask, you need to answer yourself, right? So basically, this is it again. So, can the way we build underground help us survive above the ground? The way you build your underground, does it help you survive the above the ground? So there's a connection between the underground and then the ground. Yes, I know in geology. So when you were talking about there's I actually remember a particular law that what happens in the subsurface has a way of connecting to the surface, right? So when you have a valley on the surface, definitely there is a mountain building up, right? So something of that kind of nature. I'm just saying that what we build on the underground has a way of affecting the above ground. So now, to help us unpack this intriguing question, we have an amazing guest on the show, which is Mr. Mohammad Karbakhsh Ravari. So he's a geotechnical engineer. I beg your pardon, I might not really know how to pronounce the name very well, but he's gonna do justice to that. So I sincerely apologize. He's a geotechnical engineer and a researcher whose work spans deep foundations, offshore systems, and also energy techniques. So, Mr. Ravari, you're welcome on board to the podcast. So you're very much welcome. So we are very honored to have you here. So we would like you to introduce yourself briefly. Just tell us about yourself, your name. Most Charlie, you tell us how to pronounce the name very well, and then you go ahead with the introduction. Thank you so much.
Hello to everyone, and I am so honored for being a guest in this specific and amazing podcast. And of course, I'm going to say thank you for having me. I am Mohammad, and my full name is Mohammad Karbakhsh Ravari, and you just can't call me Mohammad. I am senior geotechnical engineer with over a decade of experience at the intersection of civil infrastructure and sustainable water system. My work spans two critical frontiers: designing resilient offshore foundation for wind farms and ports, and developing urban hydraulic solutions from flood protection system to earth dam and tunnels that adapts to climate challenges. At the International Institute of Numerical Study of Geofoundation Structure, or simply IGFS, I leverage advanced tools like Plaxis family and GeoStudio family to tackle problems like coastal erosion, submarine cable trenching, and tsunami-resilient breakwaters, mostly sensory for projects like the Chabahar port expansion and a 200 megawatt offshore wind farm in different gulfs. On the urban side, I've designed paragraph for high-rise buildings, cut and cover tunnels for metro systems, and flood mitigation systems for city with coastal features, where rising waters threaten infrastructures. What drives me is the fusion of geotechnics and hydrology to build systems that aren't just structurally sound, but environmentally sustainable. Whether it's optimizing seepage analysis for dams or retrofitting aging oil platforms for rising sea levels, I believe engineering must anticipate the changing planet. I'm thrilled to discuss how we can future-proof water system today. I'm at yours, my friend.
Okay, amazing introduction, Mr. Muhammad. That was an amazing one. Honestly, you got a lot of experience, I must commend. And I believe that your experiences, we have a way of, helping and developing the water system, being a geotechnical engineer, right? So we talked about, I seen from your introduction, or I gained from your introduction about how you work with, how you build systems, which are working with the offshore and the rest. So it's an amazing one. All right, so we are going to kickstart by we are going to kickstart by asking you a few questions, right?
Okay.
So we will love you to do justice to those questions, and I believe our listeners will be really amazed to gain from your wealth of knowledge. All right, so just a quick one here, Mr. Mohammed. So we know that stuff lies beneath the surface, right? So now, what lies beneath the groundwater and infrastructure connection? What are the connections between groundwater and also infrastructure buildings and connection? I don't know if you understand me. What I'm saying is that, um, you know,
Yes, I understand it
water.
completely. Don't need to explain it more. I can jump in and
Okay, let
continue
me
to
just,
answer.
just for the sake of our listeners, many
Okay.
people think of water sustainability as a subsurface, as a surface level issue. Now, when you talk about sustainability, people think about it's just a surface water issue. Now, like the rainfall, like rivers, dams, but your work reveals how the ground beneath us plays a key role. So, could you explain how this geotechnical science lies or ties into water systems? That's just it basically.
Very amazing and interesting question, and it could be answered from different kind of perspective. But one thing is very important: ground and surface and underground. We should think about them completely and consider them completely as a live objects. Okay, one special fact is over billions and billions people are just depended their lives on the underground water reservoirs and underground water systems, and using the rivers and rainwaters or whatever different surface water systems which going to be naturally exist in the planet is not that much acceptable for the huge amount of people, population, like different countries and continents to support them. So we are so dependent on underground water, which comes from, of course, going to be completely fed from the rain or falls or rivers or glacier, whatever, in the thousands of the years. Underground, we have a new world, different layers of the soils, different concept of the stratigraphy, and it's amazing world. When you are digging underground, you can see the amazing world of living source of our planets, and of course the catastrophes comes from the water underground. We have two different concepts here. We should separate them: on subsurface waters and underground waters, and they are so different. Okay, we are talking about underground water, the quality of the water, how much water do we have, how we can control it, how we can use them, and how much we are allowed to use them, and what we can do to save them for the future generations. This is very important part. And considering this specific concept as underground water and its importance give us the duty as civil engineers, geology engineers, and whoever works in the world of planet and the work of geology, and whatever it's going to be depend on the underground system, should consider the water very important. Right now, we are facing a tremendous problems with the water, underground water reservoirs, because it's getting very small portion of the volumes and reservoirs going to loss, and we are facing a lot of global issues for continents like Africa, like some parts of Asia. People does not going to have that much surface water, that much rain, okay, and their lives depend on everything goes underground, and we should keep it, we should make it safe, we should control it, and do not let get polluted, and it's very important. So To answer your question, we should consider underground water as our main subject, not a subsurface water. We talk about subsurface water, specifically urban subsurface water with a lot of sewage and wastewaters, and it's going to make a lot of trouble. But underground water normally consider near more than 20 meters to 100 meters or more underground, and different layers of the soils like rocks or clays and sands can cover it. And it's a specific ideology. People think there are some voids underground, which they are, but normally underground waters comes from a saturated environment, saturated media, and the water exists in between the particles of the soil, and between two layers of unpermeable systems, maybe one layer of the rock, one layer of the sand, and under the sand you have one layer, another layer of the rock, and that layer of the sand is completely filled with water. Okay, when we are going digging a well, it's not like we are getting to jump into the pool of water underground. Actually, we have some kind of system like that, but this specific underground water system is a saturated system, and you should creating wells and extracting it very good. But this is amazing. When you are creating a well, you are passing through different kinds of the layers, and everything going to show you what you are facing, the material properties and the strength of those materials, how much is the value of this water, and how we can control it. Okay, I think I get the gist of the answer you needed for your question. I am waiting for you, Victoria.
Yes. I was actually carried away with your awesome yes analysis, and how you did justice to the question. Just very, very, very understandable. Yes, the way the just to recap what you said, that we need, in as much as we want to, we want to sustain our water. Sustainability don't just lies in the surface area, but also in the subsurface aspect of it, which is, we talked about having different layers on the ground, and of which people need to understand that, see, there are different layers. You don't just, it's not just a layer, there are different layers on the ground, right? So it depends on the kind of for me, I know that in Africa, or within the place, I'm from Nigeria, and then we have something we call the Niger Delta Formation. Yeah. So when you're talking about the geological aspect, we have the Niger Delta Formation, we have the Agbada, and then we have the Akata. So mostly in the sedimentary terrain, the groundwater is usually explored. For those in the sedimentary terrain, the groundwater is usually explored in the you find it more in the Niger Delta axis. So that is where you get the groundwater we use mostly, right? So I don't know about the
Okay.
geology of your area, but I'm talking about the geology of Nigeria currently. So then when you're talking about oil drilling, then you're not going to the Agbada and then the Akata, stuff like that. All right. So now it not all boils down in which terrain you are. So now these are key things that people need to understand, that it's not about the river, it's not just sustaining the river, the dams, but also looking at the subsurface, and what would prompt, or what engineer this groundwater to flow basically matters a lot. And you talked about the pores, how, formation, how those particles connect with each other and enable water to be sustained in this reservoir or as aquifers, right? So these are key things people need to understand, that
Of
it's
course, yes, it's very important,
yeah,
and
okay.
people need to understand the aquifers' roles and how we can use them and how we can sustain them. It's very important.
Yes, basically. So thank you so much for that. I truly appreciate that aspect. All right, so we're moving quickly to the next one. On that, okay, just before we move to the, I just want to say this, that the technical sciences gives us the tools to study how these materials behave, right? So it's for us to, why I asked that question, for people to understand what happens in beneath and how they can sustain it, right? So in as much, I am not kicking against the fact that we need to sustain the surface area, I'm also stretching it more on sustaining the subsurface area too as well, that there are basic things we need to know, and there are materials that behave usually Like, there are things we need to know, that these materials behave especially under the stress of urbanization. So we are trying to develop our country, we're trying to develop our regions, our area, it's key thing to know that our urbanization has impacts or can cause havoc in the subsurface, in as much as we can talk about drilling or extreme weather, right? So can also be of maybe be of a disadvantage too as well, right? So from the strength of knowing your permeability, you talked about permeability of the soil for groundwater recharge also matters a lot for groundwater recharge. So these are key things that people need to understand. So not just drilling for your drilling for the groundwater, drilling to have water. You also need to know important things that will engineer proper sustainability of the groundwater. So thank you so much, Mr. Mohammed. So we are moving basically to the next one. So I know some of our listeners will be wondering, how does this matter to me? Like, I just have to go drill water, it's none of my business. Or probably some people don't even know how drilling occurs, so they just know that once I on the tap, I open the tap in the kitchen and water flows, so it's none of my business to know what happens beneath the surface. So it's also important that groundwater levels are mismanaged. So these are things that people need to consider. And then, or structures aren't built or proper foundations aren't made, right? So the entire community will also suffer for it. So if you feel that, I'm talking basically to our listeners now, if you feel that it doesn't matter, it's none of my business, it's going to matter to you, it's going to matter a whole lot, right? So because if you fail to play your own role as a part of the community member, you will also have to suffer for your negligence, right? So thank you so much. So we're moving to the next question, Mr. Mohammed. So how do we adapt to this changing environment, right? So how do we adapt to the changing environment? What I mean basically is, so we are building for the unknown, right? So we are building for the unknown. So how do we adapt to the changing environment? So now let's bring it in this aspect. We are seeing some kind of floods, shifting water tables, coastal erosion from our experiences. So how does geotechnical engineering help us to adapt to this changing environmental conditions? So how do you think that geotechnical engineering can help us adapt to this changing environment? I don't know if you understand what I said.
Oh, yes, I can really understanding it. And to answer your question, I must correct again the concepts we are talking about. We are talking about underground water, not subsurface water or undersurface water, okay? It's two different concepts. We can talk about it, but when you want to refer on water inside the ground, which we use to understanding it as a reservoir, we are using it and for lives, is underground system. Okay, and for answering directly and frankly to your question, how we can do that? We should face the truth. We do not have water anymore, okay? And underground water, or sometimes 90% of the times, is the most clean and completely drinkable water without any problem. Just only one part you human need to do, extracting it. Do not need to do anything to make it clean. Ground does it for you. But this is a huge and amazing work of the underground layers of the soil. When you have a huge amount of water between the particles of the soil, the particles get the pollution from the soil and from the water and give you the clean water, okay? So this is the huge treasure. We do not have it anymore, because we're using it randomly and recklessly just for agriculture, or giving us 1,000 years of water and and Mother Earth let us to have it. But right now, every population going to use it as their own benefits. If they want to have agriculture fields, they are going just to dig some wells, done, without hesitation, to think what's happening. This is not just a simple water. If you want to use river water, if you want to use water behind dams, if you want even to use simple rainwater, whatever, you need to make it clean, and it's very expensive. But what's happening underground water, not subsurface water, underground water. We're talking about over 50 meters underground water. That water is purely, completely clean. If humans are not going to pollute it, but right now, if we are going to believe that water is a completely clean water, just need to extract it and drink it. This is the huge treasure. We should consider it, which we are disgracefully destroying it all around the continents of the world. Those not important in the Middle East, or Africa, or South America, or wherever. Specifically, countries with huge amount of deserts. People need it, okay? People need it and they are using it. But when science get advanced and we are starting to trust the scientists and understanding and using the science to look underground and see what is happening, we are facing the tremendous catastrophe. What are that? We do not have any more water. And if you are believing that water could be replaced by next rain or next 10 years rain even, it's a completely lie. If you have it done. If you extract it, it's not going to be replaced as easy as much as you think, and people in the world think. Okay, it's the dig a well. It's going to be always be filled with water because we have rain, we have glaciers, we have rivers, whatever we have. That water needed to get penetrated inside the ground. Okay, it's happening. Very good. It took years, but extracting flux and infiltrating flux of the water inside that reservoir does not match each other. The water needed to infiltrate it for decades, but you extracted it in months. How the water can get replaced does not have time. And what is the most catastrophe problem all the world going to face in the absence of that specific parts of the saturated place? Land subsidency, my friend. Destroying that specific part underground. Imagine you have 4 layers of the soil underground. First layer is clay, okay, for 10 meters. Another 10 meters is completely unpermeable and is not allowed to use water go around it. And the third layer for 5 or 10 meters thickness is a sand layer with a lot of water inside it. Okay, when you are getting out the water from the particles, and it's going to replace itself with particles, not with air, with new water. The particles going to get close. Particles of the soil going to get close to each other and touch each other. And in scientific terms of geotechnical science, it calls getting more effective stress. I'm not going to get inside the specifics, but listen to me. Reducing the volume of your reservoir, and that layer going to get shrinks, and the top layer of rock is going to get down for a couple of centimeters, but the domain of this reservoir is hundreds thousands of square meters. And when 30 centimeters of the second layer rock layer going to move as settlement system, that cause meters, 10 meters, 5 meters of land subsidency in the urban area or in agricultural fields. What does that mean? You do not have any more water. The water was the treasure. You lost it. You don't let the nature going to replace it. Now the water extracted, everything, the volumes of the soil going to shrink. You're facing a lot of surface settlement, and it could cause a lot of difficulty in the surface complex residuals and houses. Everything going to face a lot of differential settlement, and I don't know how to say it, it's not going to be possible to use them. So it's a catastrophe we are facing right now. Using the water is amazing. We have a very amazing source of the water underground. We do not appreciate it enough. We are misuse it. Now we don't have water. We cannot let the nature to get to it, because the extraction flux is 10 times more the infiltration flux. And the water comes from the rain, takes 2 years going to that specific place. I am listening. Please continue.
No, go on, go on. I actually
Okay,
said what you
okay.
said was
So,
correct, right?
what as a conclusion of your second
Influx,
answer? Okay,
infiltration rate,
yeah.
yes,
What is
is,
happening
and then the
here?
water that comes in,
Oh,
it's
okay, which,
it
okay,
takes
because of the
years
we are
for it to.
using the different kind of platforms, okay, for speaking. Sometimes I have delay in your speaking. Don't worry. You continue, then I can start. Please tell me what you want to tell.
No, go on, please continue. Go on, go on.
Okay, as a summary and conclude for the answer to your second questions, what people should face here is their truth, is the reality, is the catastrophe. You lose the greatest water without need of any cleaning procedure. You can't use it. But you are replacing the water with a lot of urban waste and sewage, and you are pushing that much polluted water underground because you are creating a lot of structures with huge amount of weight, and it's going to push water underground more and more and polluting the system. But before that, you're extracting every drop of your water. What we are facing is a lot of problem with the water. What water we are drinking? Yes, in the start of my speaking of your second question, I told you the amazing of the work of the ground is when you have water underground, you can have clean water. But subsurface what ground? What is that? Amount of water start from the surface to the at least 10 meter or 12 15 meter underground. That's the subsurface. That's the ground without any possibility to control the pollution of the sewage. And you, if you are going to extract it, you are going to face a lot of problem in your health. That water is not okay to use, my friend. You should separate those concepts. Underground water, we are facing a lot of problem because we are extracting the last drop. We do not let the nature to going to fill it up because we are going to starting the extracting wells with electrical motors, and it's going to work days and nights and extracting everything. So we do not let the nature going to replace it. So we are facing land subsidency, a lot of problem. So we are going to replace it with subsurface water in urban area with a lot of sewage. That specific water going to cost you millions of dollars to just get clean for you to using it. So before it's going too late, please control your extraction and believe in science and trust your scientists. I am waiting your third question, my friend.
Thank you so much, Mr. Mohammed. That was actually that was actually an exciting one. Honestly, I learned a lot. And one key thing I want them to take home is you said something. You said our extraction flux is 10 times more than the infiltration flux. Honestly speaking, that is just true, right? So
Yes.
we want to extract, and nobody cares to how do we allow nature to do what, to help replace the amount of water we are extracting. Nobody is thinking about that way. Just few persons, right? Just few of us are thinking of, oh, how do nature this time around, how did nature do its work in replacing whatever we have extracted from the underground. It is a very key thing, and I hope our listeners are actually getting a lot. So thank you so much, Mr. Mohammed. So just to add one or two, um, like I said, we are not building stronger structures. We are building smarter systems that anticipate stress and protect both people and water resources. So these are things that we should be looking at. How do we maintain, like you said, how do we maintain our underground? How do we sustain it? How do we keep it from stress? Because the underground water is being stressed out, our daily extraction. So we need to protect it, right? So it's very, very, like he said science needs to come in place, right? So there are smarter ways we could do this. And then I believe that when you play your role, the government plays its role, everyone, I believe all hands will be on deck, and then we'll achieve better results. All right, so moving to the third question. So let's talk about applications, and I would love for our listeners to hear from you your real world experience, right? So now let's talk about this application in the real world. So what are some exciting ways where geotechnical knowledge is being used today in offshore system, offshore systems, groundwater sustainability, or even geothermal projects. So yes, I believe you've worked with, you've done some offshore projects. So how do you think that these are their practical ways whereby our listeners can gain from your wealth of knowledge, where this the technical knowledge can be applied in today's offshore system in groundwater system? Because they want to know, some persons listening might not really understand, how do I sustain my groundwater? Not please, I want us to know this. In as much as we're talking about groundwater, we can't leave the surface water, because the surface water recharges the groundwater, right? So I want us to understand that, how do we sustain it now? So to you, Mr. Mohammed, so what are some exciting ways you think that your technical knowledge can be of use in today's, in offshore system, in our groundwater sustainability, and even geothermal project? So can you help us? I don't know if you got that correctly.
Yeah, I think I got the gist of your questions. And
I
let's
think.
get into it. Okay, I want to connect two different concepts of the science: offshore system, clean water, and of course, underground water. How we can connect them with each other. Listen to me carefully, my friend, and all the listeners. Okay, this is a very new technology. First, let's face it. If you do not have water as underground water reservoirs, done. You don't have it. Please, for the future, if you find some reservoir of underground water, do not touch it. Let it be there. Not because you are going to use it, because you need it. No, no, no. Because if you are going to extract it without any hesitation, without any thinking, right thinking, you are going to face land subsidence, you are going to face a lot of sinkholes, a lot of problems. So don't use it, even inside, in the middle of the desert. Okay, what is the sustainable substitute approach? The science is getting advanced. Let's clean the ocean water. Let's clean the water offshores, from the seas, from whatever unclean water you're having. We have billions of liters of water right now, all around the coastals. Okay, imagine Nigeria is a coastal features country, and you can simply create a source of drinkable water for the whole continent of Africa. How? Creating a lot of water cleaners systems, very good, and transfer those waters from Nigeria to the center of the Africa. How it is possible? I am doing it. I did doing it, and people of Iran doing it. Around all around the world actually doing it. We're having a lot of water sources all around Iran. We have the Caspian Sea in the north, we have Persian Gulf and Oman Sea in the south. So what did we do? We are cleaning the water, we are transferring it thousands of miles from the south of Iran to the center of Iran. Now we have a new source of water, very expensive water, consider it very expensive. What it fix your problem? What problem? The industrial problems. Do not use your underground water reservoirs. Please do not use it for industrial problem. Do not fix your industrial waterless problems with underground drinkable clean water. At least use subsurface water. What we did as my own experiment in my own city and my country, I'm going to make
Sorry, just a
examples.
question. Sorry, can you hear me? Sorry.
Yes, yes.
I want to correct something. Yeah, you were saying that we should, when we are building our industry, we are having projects on the industrial basis, right? Stuff like that with the industry. You're saying that we should not use our subsurface water to work. Instead, we
Not
should make use of the
subsurface
surface.
water, my friend. Underground
Okay?
waters. I tell you 10 times. Okay, it's two different concepts. Subsurface water is the water comes from the sewage of the peoples, okay, from whatever water comes from the I don't know populated urban area, okay. It's going to be embedded under the ground, maybe from the surface to the 10 or 15 meter 15 meters underground. Underground water is start from 15 meter to 100 meter, okay. So if you're talking about both of them, please separate them so I could not get confused. Continue, please. Ask me.
I think I've been cleared. I wanted to, so our listener will get that perfectly. Thank you.
No problem. So you were saying, please continue.
You spoke something about, where you were kind of encouraging us to, or the listeners, that when you're working with, when we have stuff to do with the industry, you were encouraging that we should make use of, you said something. There's the groundwater. We should not make use of we should make use of our subsurface, or we should make use of our groundwater. I want you to clarify that aspect.
Yeah. Uh, Actually, I lost the latest part of your question because of the bad connection with internet. Please repeat it again. The latest part.
Before you proceed, you said something about what we have to do with the industry. I think this time around you're channeling this to those in the industry, or those that have projects to do with industrial based stuff. Right? You're encouraging them they should not use their groundwater to. They should allow the groundwater to just. Yeah, I want, because I really did not get that part. So I want clarity. So if you could help me on that part, I would appreciate it.
Yeah. Give me 1 second. Look, I'm going to talk about the water purification system, okay? And it's very important. To the people who are listening, and people all around the world who want to understand this specific new concept of the offshore system. Normally, people think about the offshore structure, about I don't know, monopile system, wind turbines, and maybe platforms, gas platforms, oil platforms, other stuff. But we have a new concept of offshore system, and it calls extracting water water purification system, getting the water as much as you want from the sea, and bring it into your system, into your town, and purify it with your different kind of, I don't know, industrial systems, whatever you have, and then inject it to the system. Listen to me carefully. We have 2 different or 3 different kinds of purification possibility. We have level 1, level 2, level 3. Level 1 only can be used, okay, for industry, not even for animals or for agriculture. It's not that much pure, okay? You cannot spend that much money on it, and you can use it for industry, as steel industry or tire industry, whatever different kind of factories you want to use. The second level of the purification of the water could get a little more expensive. You can use it for agriculture without any pollution from the sea, without different kind of pollution from the sea. You can give it to the animals, okay? And this is very great, which is good, okay? But the most expensive part is going to be using that water for drinking, and you want to make it a drinkable water. So what should we do? We should create a strong industry to our governments, for our economy, to get richer and richer, so that government can use that money to create new purification systems for water. That third level of the purification water could happen and could completely cover a city. This is a very smart solution, actually. Could fix the water issue, global issue. Remember, the next war in the global war is not going to be based on the oil or gas or energy. It's going to be based on water resources. And it's happening between states. We are facing it, we are seeing it. Because we can have oil, okay, it's good. You are losing it, you are using nuclear. You are using it, you're not going to using it, you are using winds, you are going solar, you are going to whatever different flexible energy sources. Very good. So it's not that much important right now. But if you do not have a water, you're not going to live. So the next war between continents in the world could be based on the water need, specifically with the countries with this much issue. So the new concept of offshore could be water purification system. So let's use it. Countries all around the world with coastal features can help inside themselves and other countries. It's a new source of business also, and create a new perspective of business for the governments, and create amazing opportunity for your governments to control water resources for the whole area, not just your country. You can feed the north side of your continent. Different kind of parts of the countries in Africa, like center of the Africa, like I don't know, maybe Congo or different kind of countries. I don't know all of them. They are not have the coastal features. They are going just dependent on the underground water. They are going to face a lot of problem in the futures. Screw the system of this settlement and land subsidency. If you don't have water, you do not have enough time to reach it again and let nature to fill it for you. What should you do? Okay, that's the reason we should look into the new parts of the science, believe what we lost, accept it, and go move forward. We cannot use new and find its source of underground water even because if you are going to use them, you are not going to have water for any fountains inside the ground, for animals in the jungles, everywhere in the nature, environmental system. You are destroying it. You are destroying the aquifers, and based on that, a lot of environmental parts of your countries, your country's going to face it, and it's bad. But what is that? The next part. Okay, we find a new source of water. Very good. Let's clean it. Let's create a purification system of water. Amazing. Okay, let's inject it. It's not like that. You cannot inject water inside underground procedure like you're injecting oil in the ground. Oils comes from the huge holes underground. It's a reservoir. It's different. The water when getting out, it's going to be instantly shrinked, and there is no places for new water to inject it. So if you lost it, you lost it good. So what you should do, find the new reservoirs, protect it as much as cost, and going to find new resources. Creating surface dams has its own advantages or disadvantages, but using the oceans and seas water as much as you are thinking is very good source, because you are humanity creating global warming. You are destroying the poles and ice. Now the water levels is going to get high. Okay, use it. You should create NGOs and help the government to understand this new opportunity to use the water from the coastal systems to bring it as offshore to inshore. This is very important, my friend Victoria, and you should think about it, and you should talk about it, I hope, in the future better and better, because for this specific part of the podcast, we are focusing on the geotechnical perspective of underground water. Very good, very amazing, and right now we pass that, because we talk about whatever is underground. We're talking about the reservoirs, how the water works. Okay, we have river, it's going to penetrate it inside the layers of the soil, and it's creating some reservoir. You are using it very fast and done. You don't have any more water because the water comes from the rain is not going to happen, and you do not have going to rain again because the climate is changing, believing it world. Why people like I don't know, new governments of the US cannot understanding it, and some parties on governments do not want to understanding it and accept that the global warming is happening. So what we are facing a huge life trend system in front of us, which are the humanity. We're creating it, we're causing it ourselves. Okay, now geotechnical perspective of underground water can help you. Yes, can help you, can find it, can give you the opportunity to create channels inside the tunnels underground and move it from the offshore system inside the system. And even you can't just have simply look into Libya. Okay, people in Libya are using this specific approach to completely cover the population in the center of the Libya. How? It's a huge amount of the concrete pipes with geotechnical engineers and water resource management scientists creating this system to transfer the water from the coast and the offshore system inside the center of the Libya. And you can see in the center of the Libya different reservoirs creating artificially, and they are using it to completely reaching the whole country. So Nigeria can do it. Every place in the continent can do it. Just thinking about new approaches. Leave the underground alone, please. I am the sound of the planet, I think. And it's really going to affect our life. Look at the China, look at the US. The people facing near to 20-meter line subsidence, 20-meter settlements. What's happening after 2 decades or 3 decades, 4 decades? Okay, you have a lot of problems. You do not have the land to grow. I don't know. You cannot have plans to agriculture. You cannot have trustable, reliable lands for even creating cities. That's the huge problem without water and underground water. So, what is the solutions from the geotechnical perspective? So, we have this always some solutions for different different kinds of the problems we are facing. Okay, you for creating the huge amount of population in the problematic situation, okay, we can do it, we can calculate it, we can prepare ourselves, we can create foundations, we can create barriers, we can create whatever we want to control this kind of settlement. But the most important thing is money right now, and you are losing a lot of money. You should work hard and hard, creating new opportunities to work harder and pay taxes, so the governments can create new area for you to grow more and more. But it's a circle of ununderstandable circle of work and spending money, which you can avoid, your country can avoid, everyone can avoid, with using their minds and their brains to just using the offshore water and bring it into your country. And when you are doing it, you have a huge amount of new trustable resource, and the population can get more stronger and more trustable, and you can avoid the wars, a lot of wars between tribes, between a lot of cities, between a lot of provinces, between a lot of peoples. This is the most important part. Okay, with the geotechnical perspective, we can create the environment, changing the environment with the new approaches, injection chemicals, procedures, materials, or creating trenches, or whatever we can to just transporting water. Okay, we are creating a transportation system for water, then using it, protecting it, and you can use it in your system. Leave underground water alone. And the best way to use the subsurface water with a lot of sewage and problems is to just do one level of the purification on it and go using it in an industry. I don't know, steel industry or tire industry, whatever different kind of industry you want to use. Okay, using your subsurface sewage on your urban area. This is different kind of engineering perspective, comes from the geology, geotechnical, hydrology, and you can use it, all of them, and fix the future. Please consider this as a new approach and talk about it more for your future podcast. I'm sorry, I speak too much, my friend. Victoria, I am at yours. Please continue.
It's all right. It's all right. Honestly, it was a bundle of knowledge, and I truly appreciate that. So thank you so much about that
No
clarity.
problem.
Yes, and also how you've encouraged every listener to go ahead and do more of the purification on their surface and then leave the groundwater alone, right? So
Yes.
this is from this is from Mr. Muhammad to everyone listening to the podcast right now. All right, so you said a whole lot, and honestly speaking, I gained a whole lot from it. Yeah. So if we can work on, because the whole thing links to, I wanted to say something at the end, that the whole thing links to back to water and health, right? So if we can do more of the purification, that would be very, very nice. And then yes, because already the groundwater has a way of, it's clean, it's sustainable. You get, so it's better we work with the surface. It's better we work with more purification and then use it for multiple purposes, for industrial, agriculture, whatever we want to do, right? So, and then coming down to the geotechnical aspect, you said a whole lot in that aspect. In whatever we are doing, we should learn. I think the key thing is how we can sustain our water, whatever application, whatever infrastructure you are doing. Your knowledge should center on, or your how do I put it, your key interest should center on how do I preserve and sustain this water for future purposes. Like you said, we've lost a whole lot a lot has gone, a lot has been done, a lot has been destroyed. So it's better we come up now and then put hands together to see how we can sustain the whole thing. Nobody's gonna build the earth. Nobody's gonna build this future for us. Nobody's gonna build this earth for us. We are gonna do it ourselves, right? So if everyone should play their role, the government, the citizens, everyone, everybody, I believe that we'll not be having water issues the way we are suffering now. Climate is hampering on us.
Yes, of
Climate
course.
issue, yes, climate issue is there. So if we play our own role, I believe that groundwater will be something that we can fall back to whenever. Yes, because when we allow it to rest, the whole thing is that the groundwater is being stressed out. We can allow it to rest and then see how we can make use of what we have in the surface and see how we can better plan, manage. If it has to do with creating better scientific approach that will help sustain it, then we can do it. You listed out countries who have buy into this ideology, and I believe it's working for them, right?
Yes, completely you're right.
Yes. Yes. So I believe that for we in Africa, I would say we have a long way to go, but I believe that it's something that when we have it in mind, we can do it. So thank you so much. I truly
No
appreciate that.
problem, my
So
pleasure.
quickly before we round up, we have this last question for you.
Okay, shoot.
All right. So this last one is, what practical advice do you have for the emerging engineers? The
Mm,
emerging engineers. What practical advice do you have for them? Yeah, because our listeners are, some of them are students, some of them are graduates, some of them are professionals, right? So now, what practical advice do you have for them? Or decision makers trying to create sustainable water infrastructure? How do they build this sustainable water infrastructure?
very
So,
good.
what advice do you have for them?
Okay, very good question. Let's talk frank directly to the scientists, to the engineers, to the graduate, undergraduate. We are talking about. I'm talking right to the people of the academia right now. Okay, so please do not afraid of new subjects. Please get engaged with multidisciplinary subjects. Please get encouraged and go find practical subjects. In the field of civil engineering, we can fix the infrastructures. But in the university and academia, whatever the science is going to move, in the consulting companies, whatever, they need to understand what is the most issue here, the infrastructure, the water resources. Change the topic of your thesis from unpractical, useless projects to most practical, experimental, and most better subjects. Talk to your supervisors. Go create some riots into universities. What is that? Talking about something is not going to fix up your population, your problems in your city.
Nice
Please,
one.
it's very important to consider as a good conscience of a scientist and student to be brave, to not afraid of new topics because some professors is going to be mad. Screw that. Some professors is not going to let you be more pushy. And think about the future of your hometown. If you are getting better knowledge, if you are going to learn more and more and experiment more and more, you can help your own hometown, your family, your people. It's not going to happen when you are choosing unpractical, ridiculous subjects for your thesis and your researches. When in a population like Nigeria, or maybe different kind of countries better, for example, the countries are peoples without any water resources, just dependent in underground water. They shouldn't go through the subjects of, I don't know, talking about birds, talking about animals, talking about civil infrastructures, about, I don't know, different kind of. I'm not going to disrespect to every field of the science. I respect that, but specifically, I am talking to the people of the geotechnical science and water resource management and hydrologists. Do not think about the mountains, the rivers. Okay, we have a mountain. That mountain going to face a lot of cloud. The cloud going to give us rain. Okay, Lord, praise the Lord. Good. Praise the Lord. Amazing. No, forget it. Bring water to your hometown based on the new knowledge of the structures. Creating those infrastructures from the nearest part of possible. Change the concept of study and be more brave. Go abroad, creating the new environment of study with new concepts and new subjects. This is frankly the best way. Creating the new generation of the scientists, the graduations people from the university with understanding the possibilities of the what is the most important in front of you in the future. What is the most important problems in the future in front of you, people? Think about it. Fix that in your population, fix that in your own hometown. This is the most important part as a person who wants to talk directly to academia. Okay, so let's not fight with each other because I am facing in academia and papers reading this kind of stuff with a lot of people and tell them why you are doing this when you can fix a huge problems in your city because you have the source internet. You can connect to the different universities, bring the knowledge from outsiders, and you can create new, I don't know, guest lecturers and learn and research. So you choose the most easiest subjects in your class, in your field. What are you? If you are lazy enough to just go to the shortcuts, go to home and do not get out of your room because the reality of the world is too much for you. But if you are strong and you want to make change, please dictate the most needed, dictate the most practical subjects to your own faculty members into their brains. Please change your ideology about the ridiculous subjects and get more interesting, get more curious about the main problems of your own hometown and fix that. Besides all of it, and when you want to make a conclusion at the end of this podcast, I think it's talking too much. As perspective of scientists or people who worked decades for civil infrastructure systems, always trust your heart, be brave, and study hard purely, and act, not stay. Just act today. It's very more important parts of your life. If you learn, you should act based on whatever you learn, and you get experience and you get better and better. Finally, you can serve your community. That's the end goal of humanity. Help each other and help out each other and get better and create a community with great beliefs, without problems and without any worries. Sorry to speak too much, my friend Victoria. I am at yours.
Thank you so much, Mr. Mohammed. Seriously, that was very, very incredibly insightful, honestly speaking. So I believe that someone listening just had their entire engineering perspective reshaped and their geological perspective reshaped. Yes, because it's a call to action basically. Because tell me how you are making a research and then it doesn't have any role to play in your community. It doesn't have any role to play in your own self personal development. You are just doing it because of the sake of I just want to graduate. I think it's a call to action whereby this is just a straight bullet to the student on this call, that when you are making research as much as possible, sometimes you could be in a log hell with your supervisor, which I would encourage you to be in a disagreement terms with them, but see how you can come up with a term where both of you are in the same level, in the same dialogical level, where you could just explain to them, this is what I want to do, please, man. This is what I want to do, because you search for a problem. Yes, look for that's what I did basically. Yeah, because it's my own time, but it was not easy, But I thank God that my supervisor was someone who I already had a connection with, so she understood what I wanted to do. So I already had this foreknowledge because I saw a problem, yes, where water was one kind of Imagine someone, you just get a bucket of water. Your water is not clean. It's brownish. And I felt like this is not supposed to be so. Why am I using brown water to bathe? Like, for crying out, and it was a big problem for me. And I thought it wise and see, I need to find out what is causing this problem and how to tell people that your water don't have to be. It needs to be clear. It needs to be clean. It needs to be tasteless. So why will you be having a bucket full with brown water running from your tap? And you are using it, you are comfortable with it. What is the problem? And I got to find out that was when my will I say my love for hydrological studies began, because water quality and water availability, and I got to find out that we caused the problem because of industrial or urbanization in that particular locality.
Unfortunately, you are
Yes,
right.
yes, because urbanization came to play, industrialization came to play, and then you find out that the iron content in the subsurface was now too much. It's not something that is not showing literally, it's prone. You can see it evidentially in your bucket of water that the iron content now, it's literally, it's telling you that some, one thing with people don't understand as a geologist or geophysicist. I always tell people that the earth speak. If you will listen, you will hear. Well, why me? For those in geophysics, we talk about seismic. When you talk about seismic, I don't know if you know about seismic. We said the earth speaks through the. When you use when you're going through seismical interpretations, right? So for me as a geologist, I always pay key attention to my environment. When it's changing, I will want to know what causes it, right? So this, but because people are negligent about stuff like this, you don't get to know what happens, and then you just see it as a normal thing, not knowing that there's a warning that is giving you that, see, something is happening. You have to pay key attention. I will bet you that in 40 years behind that time, it wasn't like that. But because of the frequent industrialization, urbanization, and a lot of chemicals that are being thrown into the environment, and without proper disposal, it has a way of hampering our own health. So these are things I looked at and I was like, no, it's not supposed to be so. And I kickstarted my research work on it. So Mr. Mohammed has said, honestly speaking, that you don't take a project that doesn't have key roles to play to your environment. Try and look for something that, yes, and I buy into that idea, because try and look for something that by the time you are done with it, you'll be satisfied that yes, I play major role in solving this problem in my locality, in my country, in my region, right? So to every professional of this call, is a call to action basically. It's a call to action, and I encourage each and every one of us to buy into that idea. Probably maybe you've done your research work before now, and then you did it for doing sake. You can also kickstart and look at problems and then see how you can provide solutions to those problems. So thank you so much, everyone. Thank you, Mr. Muhammad. Thank you for being with us today. We truly appreciate. So this conversation really peeled back layers, right? So it peeled a whole lot. It peeled a whole lot. Seriously, a lot was trashed out, and it's both of the earth and of the thoughts. Yet, so it's really a wonderful time with you. Personally, I learned a lot, and I believe our listener. I will also encourage everyone listening to this podcast over and over again, right? So that is what I do basically. I just allow it to play until it sinks down to my knowledge, until it sinks down to my bone marrow, right? So now, thank you very much, and we truly appreciate. So to our listeners, don't forget we are building. Don't forget that what we build beneath us directly impacts what we can sustain above. Right? So whatever you were building beneath has a way of playing in this above or in the surface. You get to see it now. So play your role, I play my role,
Amazing.
and I believe the world will be a better place for each and every one of us. We talk about water. Water is life, and sustainability is key. I always say that in water is life, sustainability is key. If you have it today, what about tomorrow? Think long term. As an engineer, as a geologist, whoever you are, whatever profession you are into, think long term. You have it today, what about tomorrow? What happens? If it's not there, that means you're gonna die. Is that what you want? Right. So think about sustainability. So think long term. So this is where we're going to draw the curtain for today. Thank you to everyone who has really stick to us, and I encourage you to please follow, share, and continue continue the conversation with us at Hydro Vision Hub on our LinkedIn. We're there, and also on YouTube and also Spotify. So please share, comment, and we truly appreciate you all. Till next time, stay curious, stay informed, and stay visionary. Thank you all.
Very good.
Let me know. End the record.
The podcast is finished.
Yep.
Oh, okay. So very good. I'm going to just one sentence added to end if you want, and I am going to say in the end of the podcast, I am so honored to get involved with your podcast. Thank you for inviting me, and I hope you can get more stronger in the base knowledge of the water resource and go move forward and encourage all the scientists, all the graduates, and everyone around you. Thank you very much for having me. And
You're
I am
welcome.
stopping the recording right now.